Hello. Hello.
Good evening, sir.
So before starting, if you have any doubt from the previous lecture, then you tell me. Okay. So my screen is visible, right?
Yes, sir.
Okay. So I think so. We can start with the last session. So whatever we have done, I mean, it's a beta function and the gamma function. Then we will be doing the double integrals. Okay. So this is your sixth tutorial session. Um, yeah. So last time also we studied this beta function, beta and gamma. These two we have already studied, but this we will do few more questions from beta and beta function and gamma function. So I hope all of you at least know the definition of the beta function and gamma function, right? So I will also introduce that, and then we will do some questions based on that. Then after that we will go to double integrals, which will be more interesting, I guess. So yeah. So to begin with the gamma function definition, all of you know this is defined when gamma it was introduced by mainly Euler in 18th century. This is the extension of factorial function to real numbers. Okay, so yeah, so let's write what is the definition. So gamma at a value n. So I will specify what are the values it can take. So that will be e to the power minus x exponential function time x to the power n minus 1 dx. So it's not, it's a gamma, this is called gamma function, which is not defined on at least how far, like as far as I know, it is not defined over this negative integers. Negative fraction it can be defined, but not on this negative integer set. Okay, and one can easily verify that gamma 1, which will be 1, because it will be 0 to infinity uh, e to the power e to the power minus 1 dx. I mean, if you put n equal to 1, so what will happen, this 0 to infinity e to the power minus x, you will get 0 to infinity e to the power minus x dx, and that we have seen that is 1. So and also we have seen gamma half. So these are the things you need to remember. Okay, so I'll no, I was just someone wants to join the call, so that's why I was letting the student join. So what will be gamma half? Gamma half will be square root pi. Okay, not over 2. If anyone is telling something in chat box, please unmute yourself, and you can tell me. Okay, you can speak instead of sending message, because I can't see the message now while writing. So this is also we have seen. These are the things you need to remember. Okay. So and another one definition is n times gamma. Gamma at n plus 1 will be n times gamma at n. Okay. So now let's yeah, so it is not defined on integers, negative integers. That is okay, right? So we'll see how here, so how the gamma on the fraction, negative fraction, also how we can evaluate in this lecture. Okay. So gamma, let's say gamma at minus 3 over 2. How do you write that? So to make sure that first of all, let's how will be gamma 7 over 2? That will be easy. Okay, so that will be gamma 1 plus, I mean 7, so not 1 plus 5 over 2 plus 1. Okay, what will be that? So using this one, using this, what you can write, 5 over 2 times gamma 5 over 2, right? So what will be again that 5 over 2 times gamma 1 plus 3 over 2. So that will be 5 over 2 times gamma 3 over 2, gamma 1 plus 3 over 2 can be written as 3 over 2 gamma 3 over 2. Again you write 3 over 2 as 1 plus half, and then you get 5 over 2 times 3 over 2 times 1 over 2 times gamma half, which is square root of 5. So the answer of gamma 7 over 2 is this quantity. It's 15 by 8 times gamma half, I mean square root of 5. Okay. So now knowing all these things, so first let's do this question: how can you evaluate, how can you evaluate what will be the answer for this one? This is a very compact form. So k, you take any real number. Okay, k you take any real number, and then you show that it is, I mean, okay, real number, or you can take positive number, okay, also, so no problem. So you just start with the positive number also, no problem, positive number, but k belongs to real number, set of all real numbers, it can be any real number. So what will be this, how to proceed for this question? So you knew that gamma n, so what we know is gamma at n is 0 to infinity e to the power minus x, x to the power n minus 1. But you have e to the power minus kx here. So how do you proceed? So in these cases, what we will do usually, so we try to transform the equation to the gamma function. Okay, like we change in such a way that it will be gamma function, right? I mean, it will be some kind of gamma function. So let's see how we can do that. So yes, let kx equal to y. Let's say kx equal to y, right? We transfer, we will transform it to like e to the power minus y it will be. So then what will happen? 0 to infinity will be 0 to infinity, because when y equal to 0, sorry, when x equal to 0, y will be 0. So the value will be 0. When x tends to infinity, as k is positive, we can say that y is also infinity. Okay. So that, and then e to the power minus y times kx to the power n minus 1, right? Kx to the power n minus 1 times dx. Now what will be dx? From kx equal to y, k times dx will be dy. So from here what you will see, this dx, you had dx, that will be dy over k, right? Okay. uh, yes, just
It
one
was
minute.
x to the power n minus 1.
Sorry.
So it was x to the power n minus 1, no? So how it was kx to the power n
Sorry,
minus
sorry, sorry. No, 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 no. Yeah, yeah. That's what I was just. That's a. I was trying to see that whether it is correct. Yeah, it is x equal to y over k, right? So yeah, that will be then y over k to the power n minus 1. Yeah, true. So then what happens? 0 to infinity e to the power minus y, y to the power n minus 1, and times dy over k to the power n, right? Correct. So that implies k is a constant, and for a fixed n in quantify k to the power n also a constant. So I am trying to find for each n, right? So 0 to infinity e to the power minus y, y to the power n minus 1, dy, that gives you 1 over k to the power n times gamma of gamma at n, right? Y is a dummy variable. So this is nothing but a gamma function definition. So that implies it will be, so you give a k value of k and n, I will give you the answer. I mean, if you, for a value for a fixed n and k, you have a number, a solution. Okay. So that's a thing. And here this gamma n. So this gamma n will be, what will be gamma n exactly? So gamma n is nothing but You start with n gamma of n minus 1 plus 1, that you can write. So when you have this, so then it is like gamma of something plus 1, so that will be n minus 1 times gamma at n minus 1, right? Again, so you write n minus 1 like n minus 2 plus 1, so that will be n minus 2 gamma n minus 2. So it will keep on going. You can write it as n minus, so n minus 1 factorial, right? So gamma n is n minus 1 factorial, you have to remember. So that is not n factorial. So gamma n is n minus 1 factorial, okay? Yeah, so that was the one thing. Now I'll, yeah, there will be some several questions. I want to give you some of the questions. Okay, so let's say there is a question, right? 0 to infinity e to the power minus x square x to the power 2n minus 1 dx, n is greater than 1. What will be the value of this one? I mean, how you do? So you just put x square equal to y and you check it, okay? So I am not doing this one then. So okay with you, right? Is it okay? So I mean, you put x square equal to y, then whatever will come, you will just make sure that, so this, that is, so it will be it will transfer to 0 to infinity e to the power minus y, and then y to the power 2n minus 1 over 2, right? Times, I mean, it will be 2x dx will be dy. So this thing will be dy over 2 times y to the power half, right? So what it gives, I mean, the, yeah, so this one again you can write as 0 to infinity e to the power minus y. So 1 by 2 will take out, okay, e to the power, so 2n uh, minus 1, 2n minus 1, again you have minus half, so it will be 2n minus 1 minus 1 by 2. So y to the power minus half I am taking up. So then what happens? Half times 0 to infinity e to the power minus y. 2n minus 2 over 2 is e to, sorry, not e, so it is y to the power, right? Y to the power. So y to the power n minus 1 dy, that gives half of gamma n. See, is like the integrals, first when you start the integral, that looks very, I mean, weird type of, I mean, very, this type of integral, even it's not easy to handle, but even if you know gamma function definition and all, so you can use that to show that it is like you can determine the value of the integral, okay? Yeah, so these are some very easy exercises to do for the gamma function. So yeah, so next I will do one. Yeah, so this type of, oh, sorry. So let's say you have 0 to infinity x time e to the power minus x to the power 4 dx. So evaluate this. So how to evaluate this one? So again you put x to the power 4 equal to y. So I am not doing. So this also I leave to you. So this is homework. You can say, you can just do it. Or do you want to do it here? And you can try. You want to try here?
Yes, sir.
Okay, okay. Then try. Okay. So all of you try. Then I will wait for 1 or 2 minutes. Okay. Not 1 2 minutes. But like you tell me when you are done. 5 minutes maximum. 5 minutes. Okay. Do it where is you are getting issue, or whatever what is your solution, you tell me. So this is one question. The second question also I am giving. Let's say you have 0 to 1 log 1 over x to the power n minus 1 dx. So the hint here is, then second question is, you can also again transform these two, gamma function. Okay, like one type of gamma function, and then you can use the gamma function definition, and you can determine this integral. Okay. What's the answer? First one.
Sir, I'm getting a form in terms of the gamma function, but after that, I'm getting stuck somewhere. I'm
Yeah,
getting.
let's discuss. Okay, that's a good. You at least you were trying. So anyone else trying? They got.
Sir, trying but got y to the power 0.
Y to the power 0.
Yes, sir.
No. So let's, yeah, okay. So what you did, let's discuss. That's good, right? All of you,
Sir, I'm getting form of e to the power minus y and
yes.
y to the power minus 1 by 2.
Okay, so this second one I am not doing now. So I will do later. First this one, okay. What you got? Tell.
0 to infinity integral of 0 e to the power minus y into y to the power minus 1 by 2.
Minus 1 over 2.
Yes, sir. dy.
Okay, so that dy. Okay, so who else told? I forgot the name. And he also got the same thing.
No, sir.
So what you have to do? So x to the power 4 equal to y you put.
Yes, sir.
So then what happens here? So some problem is there. Okay. So this integration will be. Oh gosh, sorry. I mean some issues with this machine. I think. Yeah, it is working now. So this 0 to infinity, I'll write instead of x, it will be y to the power 1 over 4. Right? That's true. Then e to the power minus y. Whatever from x to y directly we can evaluate, that we try first. And then what you have dx. So what is dx? Dx will be 4 times from here, for x to the power 4. So 4x cube dx will be dy, right? So dy will be, dx will be dy over 4x cube, right? But we have to make sure that it is like in terms of y, right? So from here, so 0 to infinity, y to the power 1 over 4 e to the power minus y times dy over.
Sir, yes, now I am getting that e to y to the power minus 1, right?
Okay. So you understood, right? Whatever we're making a mistake. So y to the power,
3
what
by
will this be? Y to the power 3 over 4, right? So that implies 1 over 4. So you did not tell whether it is 1 over 4 is there or not, right? 1 over 4 also is coming, right?
Yes, sir.
yes.
Okay. So then good. So e to the power minus y times y to the power minus half, right? Right? What is the minus of
Yes, sir.
dy? So
Yes.
then what will be that? So 1 over 4 times, what is this? 1 over 4 times gamma of half, right? Because you have y to the power n minus 1. So instead of y to the power n minus 1, you have y to the power minus half. So what you do, you just make minus 1 equal to minus half. So then n has to be half. I mean half minus 1 e to the power minus y times half minus 1. So then that is gamma of half. Gamma of half is this one, right? So that implies it will be square root of pi, and gamma of half you have to remember. Then gamma of half over 4. The answer will be this. So all of you got this, but just I think doing getting the gamma function, like how you do the gamma function, that you were maybe missing. I mean you could not do it, right?
Yes, sir.
Yeah, so gamma
Yes.
of half is, sorry, not gamma of half, gamma of n is, you have this 0 to infinity e to the power minus y, y to the power n minus 1 dy. So if you put this gamma of half, you will see this 0 to infinity e to the power minus y, y to the power half minus 1 is minus half dy. Right? That's what it is here. And gamma half is square root of pi, that you have to remember. So that's a solution will be square root over square root pi over 4. Okay, you understood, all of you understood, right? How you got?
Yes, sir.
So now do the second
Yes.
question. It will be more interesting. Second question, which is 0 to infinity. I'll help you in, sorry, not 0 to infinity, 0 to 1. Log 1 by x to the power n minus 1 dx. Okay, how you do? So the hint is you have to again transform this to gamma function. At least first do that. transform to gamma function. Then we'll do. Yeah, what you are getting? So what you have to do? First step, tell.
Sir, we can take e to the power minus x as t.
Okay, e to the power minus x as t, to the power minus x as t. Then
And then, sir, we can take that will mean that e to the power x is equal, or we can take log directly. We can take log here.
yeah, then that will give you minus x will be ln t, right?
Yes, sir. And if we can also write this as x is equal to 1 over t.
X equal to ln 1 over t. Okay, then
Yeah, right, sir. And then, sir, ln 1 over t, and then we can replace it in the
see
this.
when you write this one, so it will be good if you start with not e to the minus x equal to t. T is equal to the minus x. I mean, just use log 1 by x equal to t. I mean, it will be more or less same, but when you write this dx and all, it is you will be confused. Okay. So what you wrote 0 to 1 log 1 by x times to the power n minus 1 dx. So if you and now you are changing x equal to ln 1 by t, you understand what you are doing. So instead of I am telling you make it a t equal to ln 1 by x. Now
Okay, sir.
understand. So that will be better for your understanding, right? Otherwise you may make mistake also there. So
Yes.
anyway, so yeah, so log 1 by x equal to t if you assume, or e to the power minus t is equal to, or e to the power minus t is equal to x, then what happens? So first of all, limit what will happen when x equal to 0. So what is the limit when x equal to 0? Means it goes to, it blow up, right? It is infinity, minus infinity, right? What do you say? So how you change the limit first of all? So what are the things you have? I mean, this is usually we write like this. So when t is, so not t, x, x equal to 1, what will be the t value? T value will be 0. But when x equal to 0, what will be the value of t? What will be t?
So infinity.
It's infinity or minus infinity. That's what I want to know. Okay. So t should be minus infinity, right? So what is how does this log x function look like? It's like this. I mean, at it will cut at 1 0. I think, yeah, 1 0, and then as you approach to 0, this will go to minus infinity, not plus infinity, right? So that's why what I write is 0 to maybe let's write first. Let's start first. So 0 to infinity, sorry, minus infinity. Okay. I mean, it should be minus infinity to 0 mainly. So yeah, I mean, you can for now you can write is 0 to infinity. Okay. Uh, but otherwise it will be difficult. I think. I mean, see, we're taking minus infinity. Let's do it. Okay, whether we can do it. So t to the power, so log 1 by x to the power n minus 1 we have. So that will be t to the power n minus 1 times what is it, dx, right? You have dx. What will be dx? When log 1 by x is equal to t, if you take d both sides, like to the both side, I mean, before taking d both side, you take x equal to e to the power minus t, right? So that implies dx will be minus of uh, dt, minus of e to the power minus t dt. So that gives you minus of e to the power minus t dt, right? So that implies, so if I yeah, so minus negative of yeah, so that's what I was thinking that how this will be. So e to the power negative of 0 to minus infinity t to the power n minus 1 e to the power minus t dt, right? So this question, I think you just leave this question. So this has some issue. Okay, let's not do for now. I'll tell you what is the issue in the next class. Okay, I think there will be some issue here because when x tends to 0, so t should tends to minus infinity. Okay, but that's not the case here. Just say telling. Okay, so let's I forget this question. Okay, so leave this question. I will do next question. Okay, anyone you know any idea here? So what should we do? No, right?
No, sir.
So the solution, it is telling this it will be gamma n, but I think there will be some mistake because they will assume that this is a 0 to infinity. They will assume that which we should not do, because you understand that when x equal to 0, sorry, I made a mistake, right? When x equal to 0, I mean x equal to 0 in when x is converging to 0 plus 1 by x is there, right? 1 by x is going to uh, when 1 by x will go to plus infinity, and ln then 1 by x that will go to plus infinity, right? You understand what I was making mistake? So let's write it. Okay, it was ln 1 by x, I assume ln or log function, so that is 1 by x that will equal to t, I assume. So when x equal to 1, that is not a problem. Then t is equal to ln of 1 over 1, which is ln of 1, that is 0, right? So when x equal to 0, you cannot do that exactly x equal to 0. We have to take x tends to 0 plus. We cannot take x tends to 0 minus also, because it's a logarithm function which is not defined as, it does not make sense of x tends to 0 minus. So when x tends to 0 plus, ln of, sorry, not ln of, first we have to understand how 1 by x is behaving. So 1 by x will converge to plus infinity, and then ln of 1 by x, that also will go to plus infinity, because we have seen the ln graph looks like this. We need to, when something is going to infinity, then that part will also go to, so ln will also go to infinity, right? So so that's why what you can write it as this 0 to infinity, 0 to infinity e to the power minus t times t to the power n minus 1 dt, negative of that, right? So because x e to the power minus t is equal, you have assumed that this x equal to the minus t, right? So if x equal to minus t, then dx will be e to the power minus t times dt. So if you put all these things, this will be negative of gamma n, okay? So the value you got, it will be negative of gamma n. So this is done then. So you understood what I mean here? Is it okay?
So we have to take only the right hand limit.
Yeah, because when x equal to 0, exactly at 0 you cannot evaluate, right? That is true. That you understand. Exactly at 0, x equal to 0 you cannot put.
Yes,
But
sir.
you can take a limiting thing. I mean, when x is converging to 0, how it behaves, that we can see, right? When also this 0 to infinity is the integral given, that infinity you don't know, right? That is, you take, it's conversion to infinity when the limit is going to, I mean, the limit of the integral is conversion to infinity, right? So that concept here also, when x equal to 0 mean, here x equal to 0 does not exist, x tends to 0, not that point, but that conversion to 0. So here, but if that x tends to 0 also can be from both sides. Why we are taking from left hand side? Because from sorry, right hand side. Why we are taking from right hand side? Because from left hand side you cannot access, because left hand side means x is negative, but ln of some negative, 1 by negative is also negative. So ln of 1 by negative, that implies ln of negative. That does not make sense. So only the limit which makes sense is from right hand side, right?
Yes, sir.
Yeah, so that's why it is like this. Any other question or any question from this gamma function? So if you found some other question also, you can send me, I will solve it, and I'll give it to you if I can do it. These are the very easy questions which you will need maybe in many places. Okay, and so one thing you remember, that gamma, as I once I told also, the gamma for negative integers, that it blows up. I mean, the gamma is a function, right? It's a function. It is defined for all the values, but I mean, other than negative integers. Negative fraction also, negative positive fraction, everything it is defined, but it's not on 0 plus minus 1 plus minus, sorry, not plus minus, so 0 minus 1 minus 2. See, I made, I think, a mistake here. So I'll verify. So this is not plus minus 1, 0 minus 1 minus 2, like that. It will keep on going, okay? It is not defined on minus 1, minus 2, and keep on going. So this is a negative integers for negatives. And for positive integers, you have, all of you know, I think, and we have already said that and discussed that for positive integers, when it's gamma n, when n is greater than 0, gamma n is nothing but n times gamma n sorry, n minus 1 time. Let me write it in a better way so that you can remember. Gamma at n plus 1 will be n times gamma n for any positive real numbers. Okay, if n is less than 0 but n not equal to 0, minus 1, minus 2, all these things, then you can remember this gamma at n. What will be that? Gamma at n will be 1 by n times gamma n plus 1. I mean, it is same, but I mean, you can evaluate using that the formula, this formula. I mean, if you have gamma at minus half, why I said, I mean, you can say that it's just you are making from there itself. So gamma minus half, if you have a minus fraction of minus half, that will be 1 over minus half times gamma minus half plus 1. So that will be minus 2 times gamma half, that will be minus 2 times square root of pi. So yeah, that these are the things I wanted to discuss in the, I mean, for the gamma function, I have to discuss this. Yeah, and now we'll move to beta function. Okay. Okay, so what's the definition of beta function? Beta function is given by for I mean, if the gamma function was for one uh, point, I mean, for one in the one variable mainly, it's a two variable function mainly, and beta mn is given by 0 to 1 x to the power m minus 1 times 1 minus x to the power n minus 1 dx. Okay. So beta beta mn function, there are important properties. So beta mn you can write as beta nm also. Okay. And beta mn, so this is one property. So second one is the one of the important ones. So how you evaluate beta mn? So you don't know the beta mn, you just said that beta mn so exists. I mean, beta mn is there. So, but what will beta mn? So that will be gamma m gamma n over gamma of m plus n, which all of you know. Right?
Yes, sir.
Yeah, so let's do then some few questions on this. I don't do much question on here on this topic. I will go to double integration mainly. So that will be uh, interesting, more interesting. Okay. So let's do one question on this gamma beta function. So let's say you have a integration like 0 to infinity x cube over 1 plus x to the power 7 dx. First of all, try to change this one in terms of beta function. I mean, it should look like this. Look like this. Okay. So beta I mean equals 0 to 1 x to the power m minus 1 times 1 minus x to the power n minus 1. So I will keep this one so that, yeah. So you try to build it in such a way that this will be in the form of beta function. You want to try, or I will do this one? So let's I'll do let me do. Okay. So you have this x cube times 1 by 1 plus x to the power 7, right? So let's change this one to y equal to 1 by x plus 1 or 1 plus x. So then what will happen? So you can make it y in the uh, uh, denominator, right? So y to the power 7, y to the power so 1 by x to the power 7 will be y to the power 7. And from here I will find out what is x also. So x will be, so x will be 1 by y minus 1. Okay, so yeah, I think some mistake is there. Yeah, x is 1 over y minus 1. So yeah, let's do it. Okay, with something, if
So
something
it's
comes.
1
So
plus x, no?
yeah,
So
tell.
then x will be 1 minus 1 by y.
No, right? It's correct, right? This one from here to here, you are telling about this one.
Oh, sir, I have taken 1 plus x. 1 by 1 plus x is equals to y.
That's okay. Same thing, right?
Yes.
Not, is not it? Am I making mistake? Others? See, y equal to 1 by x plus 1. That implies x plus 1 equal to 1 by y. So x will be 1 by y minus 1 only, right?
Yes, sir. Yes.
Yeah, okay, okay. So, and also we'll put what is dx. So dx will be minus 1 by uh, y square dy, right? Yeah, so now it is okay. Then x will be this one, and okay. So that implies, I mean, you have to change first of all, so 0 to infinity. You had from when x equal to 0, then the integration will be 1. Y will be 1. When x equal to infinity, x is going to infinity, then y will go to 0, right? So that implies, so you have now 1 by 1 plus x to the power 7, you have. So that 1 by 1 1 by x to the power 7 will be y to the power 7 times you have x. So x will be 1 by y minus 1 to the power 3, right? You understand? Times dy dx will be negative of y square times dy. You got it what I did? So that implies, I just substitute all the values of y and all. So that implies 0 to 1 y to the power 7 times 1 minus y to the power, it's not 0 to 1, y 0, 1 to 0, right? So let me just do it. So this will be uh, 1 to 0, 1 to 0, y to the power 7, 1 minus y to the power 3 over y to the power 3 times 1 by y square, and that will be negative times dy, right? Yeah, can you see my slide? I just got disconnected from my recorder. So yeah, now it's fine. What will be this beta function? What is beta function? So beta function at mn will be 0 to 1 x to the power m minus 1 times 1 minus x to the power n minus 1, right? dx. So that's why this quantity is okay. So this beta will be then 2 plus 1 and 3 plus 1. I mean 2 y to the power 3 minus 1 times 1 minus y to the power 4 minus 1. So that's why it is. So this is nothing but beta times beta of 3 4, that is nothing but gamma of 3. So what is beta mn? Beta mn is gamma m times gamma n over gamma of m plus n, 3 plus 4. That implies, what is gamma 3? Gamma 3 will be, gamma n is n minus 1 factorial. So gamma 3 will be 2 factorial times gamma 4 will be 3 factorial over gamma 7, which will be 6 factorial. That is nothing but times 2 times 1. Okay, so 2 times 3 times 2 over 6 times 5 times 4 times 3 times 2. I mean 3 6 will go and it will be 1 over 60. That's the answer. You understood? All of you understood this thing?
Yes, sir.
So, okay, right? See,
Yes.
easy. Okay. So, yeah, this was one question. Uh, Beta function. Okay, let's do one more question, then I will move to the double integral. Okay, let me find out if there are any questions.
Sir, I have doubt in double integral that how to take the limits and all.
Yeah, we'll do this exactly. We'll do this only. Okay, wait for
Yes.
just one after this question only. After one question I do, then I will move to that things only.
Yes,
Those
sir.
questions only we will be doing. Okay, don't worry.
Yes. Yes.
Yeah, yeah. So stay for that. I mean, you have to stay. Otherwise, I mean, one after one question we will start. So how do you prove that? Yeah, let's close this beta function thing by this gamma function type of question. Okay, it's like I mean it's funny, but let's do this one. So pi over sine of n pi when n is when n is. So this is proof that I mean prove that this happens. How do you show that? Can anyone try? So how we proceed is this. So let's what is your gamma? So you can write this gamma n times gamma 1 minus n over gamma of n plus 1 minus n. I mean, okay, let's write it properly. Okay, you can write gamma n times gamma of 1 minus n is equal to gamma n times gamma of 1 minus n over 1, and that is nothing but gamma n gamma of 1 minus n over gamma of 1, which is n plus 1 minus n. Can you write this? Do you understand why I am writing like this? Who will tell? Why I wrote like this? What is this? Can't we say this is nothing but beta at n? Sorry, not n. Of course, it's making a mistake. So what is this? Yeah, it's at n only, right? It's at n and 1 minus n. Can you say this?
Yes, sir.
Right?
Yes.
So once you say that, so that is nothing but 0 to 1 x to the power n minus 1 minus x to the power wait 1 minute. This is correct, right? So n times n at n minus 1. Yes, it seems correct for me. Is a 1 minus n. Yeah, it's okay, right? 1 minus x only. So 1 minus x to the power 1 minus n minus 1. That's what your beta function definition, right? Beta mn is x to the power, let's say, beta mn is x to the power m minus 1, 1 minus x to the power n minus 1. That's here, 1 minus n minus 1 as well. So I'm just using the beta function definition. That will give you times dx will be there. Okay, so that will be 0 to 1 uh, x to the power n minus 1 over 1 plus x dx. Sorry, not 1 plus x, 1 minus x. 1 minus x dx. Right. So now we take this transformation, because we want to make sure that this is kind of looking like a nice integral. So for that we take x equal to e to the power t. Okay, so when if you take x equal to e to the power t, then this one will be when x equal to 0, this e to the power t will be minus infinity. When x equal to 1, then it will be, so what I'm telling, so you have x when x equal to 0, then t will be infinity, t will go to infinity. When x equal to go to minus infinity, so x equal to 1, so this t will be ln 1 means 0, means it will be minus infinity to 0, uh, minus infinity to 0, this e to the power something like e to the power nt. So leave this question, okay, this will be I think little difficult. So it will be minus t times 1 plus e to the power t integration of minus infinity to infinity. I mean there is a, in a complex integration there will be a result which says that this is this. So okay, so leave this one, so leave this question. So okay, sorry for confusing your world. So it was little bit difficult, so don't need to do this one. So we'll do some other questions. So we'll start with the double integral. Okay, so don't worry about this. So other than this, all other questions I think you little bit understood, and these are all of these questions will be important for your for this course, and for later also it we can use. So now is it okay everyone? Then I will move to the next
Yes, sir.
part of the talk, well, next part of the discussion session. Okay, so that will be a double integral. Okay, yeah, double integrals. So let us do the questions, and then while doing questions, we will understand how to mainly do that. So one of your assignment question. This is not double integrals. First of all, the questions I was talking about, but yeah. So let's start with the double integral questions. So at the end, I may do some other one variable, only integral finding something. So yeah, suppose you have a reason, say x y, such that x is greater than equal to 0, y is greater than equal to 0, and x square plus y square is equal to 1. So then find out, you have to find over this over this region mainly, this double integration and suffix r, that implies over the region r you have to find out the integration of a function, given function x square y to the power 4 dy, right? So when you do this double integration questions, first of all draw the domain. What is the domain? Okay, so you have to draw the uh, domain. I mean, plot the domain. How the domain looks like. Then it will be very easy. So how is that? So we first draw here what is the, sorry, it will be less than equal to x square plus y square less than equal to 1. Otherwise, it won't be domain. So what will be, like, how the domain looks like? So this is x-axis and y-axis. And what will be x square plus y square less than equal to 1? X square plus y square equal to 1 is a circle. X square plus 1 y square is a circle. Yeah, so let me just draw. So x square plus y square is a circle like this. I mean, it is the origin, and this is 1 0, is 0 1, and it's a minus 1 0. All these things are there. Okay, but this is a circle which has this x square plus y square circle with the domain, like domain is this. Whole is the domain. This is x square plus y square. X square plus y square less than equal to 1. This will be the whole domain. But when the region R will be only the, when the only those numbers will be there which are positive also. What does that mean? So positive implies that has to be only in this portion only, right? So your R will be nothing but the green, I shaded with the green color. Okay, so that will be your R. Do you see the region? Can you see? Can you see my drawing? I mean, I just to make you understand. So this will be your region R, not the whole thing. Only the green region, the green color region will be R. Okay. So do you understand that? Up to that is fine. So
Yes,
once
sir.
we know that, what we'll do, we'll try to figure out how to mathematically write that domain. Okay. So first step is drawing. First of all, once your drawing is done, we try to find out how to write in the limiting form. I mean, you have to merely write as something, some here to something, and here also some other thing to some other thing. For x equal to something, y equal to something to something, by which I can interpret the domain. Okay. So mainly I want to write in mathematical way. Okay. So to write that, what we usually do is, see, if we take a small partition, I mean small area, this table, okay, and if you vary it from this to this, right? If I vary it from, let's say x, I vary from 0 to 1, x I vary from 0 to 1, okay, then the y value, so for a fixed x, y value will be what? From here to here. But what is this line? So in this line y is equal to 0. So y will start from 0. So first you fix one, or that is x, from x is varying from 0 to 1. then why it will be from why will be this portion only? I mean from here to here. I mean, do you see this one? Let me draw again. So that is, yeah. So this region. So if I draw something like this, so y will be here. It will be 0. Y is equal to 0. But what will be the value of y here? For any point, this is arbitrary point, right? You have from 0, say 0 here, and here what will be the value here? Y will be here.
Root of 1 minus x square.
Exactly, root of 1 minus x square. So can we say that when x varies 0 to 1 and y will vary from 1 minus x square to, and the lower bound has to be 0 always. So this region will give you the region R. It's not it. Do you understand this? X, when x varies from 0 to 1, and when y is varying from x, you are varying from here to here. So this whole line you are varying. So when you fix one x and do that thing, that will be one line. So x will be another. So it will be this line. So it will be like this. For all value it is there. So it will fill the value. It will fill the region. X, when x you are varying x, and y is from the other side from 0 to the curve. So that will be the circle, or the 1/4 of the circle which you need. Is it okay?
Yes, sir.
You understood, right?
Yes, sir.
Okay. So once you understand this, then the math is not difficult. Okay. But for different questions, the reason will be different. You have to find out the reason. Okay. So once you understand this, now it will be easy. So what we do? So x, we put x equal to 0 to 1. Y will be 0 to square root of 1 minus x square. Right? That's what we found out. So then x squared times y to the power 4. So it was dy dx also. Okay. dy dx it was. Okay. So dy dx. So once you know, once you got this, so this one will be 0 to 1. Yeah, so x square is not in this. So x square you can take out, times 0 to square root of 1 minus x square, because this is a x square and y to the power 4 are differently it is given. So dy times dx. But you cannot write this. You cannot write 0 to 1 x square dx times 0 to 1 minus x square y to the power 4 dy. You cannot do, because x is here varying. Okay, so you have to keep x. I mean, first you do integration for y to the power 4, and then you get for x. Then you will get a function of x, and you have
Sir,
to again integrate.
hello, sir.
Yes, tell.
Sir, I am unable. You are when you are writing, then I after some time then I receive, sir.
Oh, really?
Continuously, yes, sir.
Hello.
Sir, continuously when you are writing, I am not seen on a screen, sir. After some duration, then seen on my screen.
Okay. Is it lagging down? So I'll maybe once
Uh,
again maybe
Yes, sir.
uh, leave
Double
and
integral. Sir. I did
yes.
not understand, sir. Double integrals. Please proceed with, sir, again, sir.
Okay, no problem. So you could have tell before, but yeah, I'll again do that. Okay. So I let me sign off, and then I will again log in. I'll log off and then log in. Okay. Let me try that. Hello. Now is it okay? I mean, can you hear me when I speak?
Yes, sir. Now I am unable to, sir.
Okay. Let me Can you now, is it okay if I write like, let's say x equal to 1? Is it coming? No, not lagging, right?
No, sir.
Is it okay?
Yes,
X
sir.
equal
Yes.
to 2, x equal to, okay, it's fine. Yeah, so let me then do it quickly for him. Yes. So what I started is this. So you have a given that it's a region is this. So let me do it again here. So your question is this: over a region R, find out the integration of x to the power 2 y to the power 4 dy dx. Okay, and the region is given by x y belongs to R2 such that x is greater than equal to 0, y is greater than equal to 0, and x square plus y square less than equal to 1. So what I was telling that you have to first make sure that you have to make sure that you are whatever drawing, the domain you are drawing, that is correct. So what I have done, I was telling here that you have your domain will be x square plus y square is less than equal to 1. That domain will be let's say, let's draw it twice. Yeah, so this whole thing will be okay. So this whole thing will be your x square plus y square less than equal to 1, right? But you have also another constraint which is telling that x has to be greater than equal to 0, y also has to be greater than equal to 0. The green region I draw, that is giving x square plus y square is less than equal to 1 for any xy such that x square is plus y square is less than equal to 1. But if I put x is greater than equal to 0 and y is also greater than equal to 0, so we know only in this quadrant, this x and y are both positive. All other this quadrants are this. So this is first quadrant, this is second quadrant, like that. This is third one, this is fourth quadrant. We say okay. I mean, quadrant when is like this whole region is this quadrant. This whole region will be this quadrant, like that. Okay. So in the first quadrant only we know is the function is the points are positive. Okay, so that's why the whole your R region R will be this. So this will be your the question in the question whatever region asks, that is this quantity. So this is the region. When you find out the region, so region, then what do? We try to find out the limit of x and y by which we can uh, write the domain, by which we can define the domain. Okay. So now here what I am telling, let's draw this. So if you draw a line here, say, and this line if you vary from here to here, will vary this line. This is one line. So you think like I mean, by a small partition you can make the whole. By a small brick you can make a home, right? By a small line, one line you can make a plane. So this line will vary, but how we vary that matters, because this line you cannot keep fixed. The fixed is not fixed line. It will be small here, it will be bigger here, but they will all have a same pattern. Like why this when you vary from here to here, that is nothing but y will be from 0 to this, always will be in this all this I mean in this line, right? So that means y has to be less than 1 square root of 1 minus x square, because that is on the uh, circle. And x, what has to be x? when you vary a line, you vary. Now when you write this y less than equal to 0 less than y less than 1 minus x square, that gives you the red lines. But you have to vary those red lines by this x to 1 to 0, because you have x from this to this. This is fixed. This is fixed, but x, it is only going from 0 to x, 0 to x only. So 0 to 1, 0 to 1. X is not varying from 0 to some point, because this is in this line, x is from 0 to 1. But y, you cannot take 0 to 1. So if you take y 0 to 1, that will give you a square. Okay? So y has to be from 0 to the point on the circle, so that it will be the circle on the quadrant. Do you understand? Who are
Sir, so
okay?
what if we will take x coordinate first, then
Yeah, that's what we are doing. First x coordinate first. So we are taking x first, x from 0 to 1. Then y will be from square root of 1 minus x square to 0. 0 to 1 minus square root of 1 minus x. Oh, you
no,
are
sir.
doing the other way.
Yes, sir.
Okay, yeah, of course, that we can do also. So first of all, I just am giving you idea that how to derive it. Then you can do in a different way also. Okay, that is also same kind of same way you can do. See, I will show you. So that you have like this. Yeah, I think a little bit problematic. Yeah. Okay, so your quadrant is this. So we want to vary this line. So initially we were varying this line, right? I want to now vary the line, for example, this horizontal line. So if you want to vary this line, so where on this line, which will vary first? So on this line, x will vary, right? X will be from 0 to, in this case it will be symmetric, you will see, I think. Okay, 0 to, see, because in this line x is varying, so x will be from 0 to, again this is, x will be on this line only, here, everywhere it will be on this one. So that will be 1 minus y square. And your, in this line you have to move from here to here. So for that you need y, which will be from, it is at 0 1, right? And it is 0 0. So y should be from 1 to 0. So this case, whatever line you take, vertical line or horizontal line, it will be same. But for different, for other questions it can be different. And so for some question, it will be easy in one of the case. One of the case it will be difficult. So you have to find out those things. So you have to optimize it. But at least if you understand this thing, that limit, like the in the region you have to make, by using limit you can have to cover the region, and then it will be easy. So then what we will do, we evaluate this. So what will be that then? 0 to, so I am writing, yeah, let's write in terms of this one, with respect to this one itself. So 0 to 1, 0 to square root of 1 minus y square, then x square y to the power 4, x square y to the power 4 dx dy. So that gives you 0 to 1 y square, y to the power 4 you can take out. But 0 to 1 to the power 1 minus square root of 1 minus y square, x square dx, you have to keep it times dy. So that gives 0 to 1 y to the power 4. What will be this? X cube over 3, which will be from 0 to square root of 1 minus y square dy. Right? That these are a simple integrations. These are not a problem. Already the most difficult thing you have already, you understood already. Okay. So once you are done with this, so 0 to 1, this will be y to the power 4 times, this will be 1 minus y square to the power 3 by 2 dy. Right? Yeah. So now can you see the, like how exactly this is? I mean, what are the is it looking like some beta function and all? Is it looking like beta function? So how to make sure that it will look like beta function? Like how to change it? So let's take y square equal to t. Okay. Then the integration will be 0 to 1. So when y equal to 0, t will be 0. When y equal to 1, t equal to 1. So that is the limit will be okay. Then t square 1 minus t. See, that's why I made it y square equal to 4. So that it will be 1 minus t to the power 3 over 2 times dy. So dy will be dt over 2 times y, that is t to the power half. So that implies half 0 to 1 t to the power 2 minus half 1 minus t to the power 3 over 2 dt. Is it okay? So that implies, so please check that whether I made any mistake or not. Okay, I don't think it's yeah. So y will be square root of 2y dy will be dt. So dt over 2 times y to the we get to the answer. Okay, y square, this is t square. One minus y square to the power 3 over 2. Everything is okay, right? What do you say? Is it okay? So let's do it and then we'll understand whether we have found any mistake. Half. Uh, is it coming as 0 to 1 t to the power 3 over 2 times 1 minus t to the power 3 over 2? Okay. So that implies half 0 to 1. I mean, what is this then? This is nothing but half gamma of 3 by 2 plus 1, 3 by 2 plus 1. So that implies gamma half of gamma, sorry, not gamma, beta. So please make sure that this is beta function, right? But beta function is nothing but, that is nothing but beta of 5 over 2 and 5 over 2. That implies half times gamma 5 over 2, gamma 5 over 2 over gamma of 5 over 2 plus 5 over 2. That implies half. What is gamma 5 over 2? That will be 5 over 2 times gamma 3 over 2. Gamma 3 over 2 will be 3 over 2 times gamma half gamma half. You understand what I am doing? If not, please tell me, okay? This will be 2 times and then gamma of 5, which will be 4 factorial, right? Which will be 4 factorial. Gamma 5 means n minus 1. Gamma n is n minus 1 factorial. So 4 factorial. That implies, so what is this gamma half is square root of pi. So this will be total will be pi times okay. Did I do any mistake? No, I think. So 15 gamma 5 over 2 times gamma 5 over 2. So whatever the answer you get, that will be the thing. So this is gamma half 5 over 2. So it won't be 5 over 2, right? So yeah, that's what I made mistake. Let up to this everything is correct. So yeah, what we are evaluating, that is not correct. Okay. So let me write this one more time. Okay. So that will be what is gamma 5 over 2? Gamma 5 over 2 is gamma 1 plus 3 over 2. That is nothing but 3 over 2 gamma 3 over 2. That is nothing but 3 over 2 times half gamma half. Okay. So from there what we get, and gamma 5 over 2 plus 5 over 2 means gamma 5, that is 4 factorial, right? That implies half times, these are for your things. So half times 3 over 4 square root pi, that is nothing but 3 over 4 square root pi square, here it will be square over 4 factorial. Okay? That is nothing but, yes, 9 pi over 32 times 4 times 3 times 2. Okay, because 4 factorial is like that. So what will be this value? Did I make a mistake here? Okay, no problem. So this will be 3 pi over 256, right? So the answer might be given that pi over 256. That's what I am thinking where I made mistake. So do you see any mistake here? Yeah, I made a mistake here itself. Okay, I found out. Great. So this will be 1 over 3 only. See, 1 over 3 I am missing here. 1 over 3. So everywhere it will be 1 by 3 also will be there. 1 by 3. So 1 over 3 times 1 over 2. 1 by 3 times 1 by 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 2. And I mean it's like 1 by 3 times 1 by 2, which will give you everything. So pi over 256. So this is what the answer is also given. And I think, yeah, correct. So tell me if you did not understand. Okay, this is the whole thing. We started with if you understand one question itself, it will be enough kind of. So this we started with this the region, and then we find out the limit for the region, and then we get the solution. Any doubt here? Tell me. If you have any doubt, please tell me.
No, sir.
Okay.
Yes, sir.
Okay. So then, if not, then we'll move to the next question. I think my page is over now. Okay. We'll do somehow. We will manage it. Okay. So let's do it here. So the small result. Okay. So another question I will make it is, let's say the question, find out the area of the region bounded by y is equal to x minus 1 whole square and x equal to y square over 8 plus 1. This is also double integral question. If you try, then you will understand it will be a double integral question. So for your first work is to draw the domain, draw the region. Please try first, try by yourself. Then tell me the limit from where to where will be the limit of the integration. No function is given, so we don't need function also. We will just integrate. So if you want to find out area of a region, so that will be just integration over. So if you want to area of a region R, that will be double integration over 1 only, right? That will be the area 1 time 1 dx dy, right? Do you understand this? So if that is so, I mean over r dx dy. But you don't know what is the limit from where to where. That's why you cannot do just straightforward way. So that's what you have to find the limit, and then it will be easy. Just it will be very easy. Okay. So try to find out the limit and tell me what will be the limit. So after that, I will continue. Okay. I mean, once you tell me the limit from where to where. Sorry. Yeah, so then we'll do the other questions, okay? So what you have to do here, you have to draw the graph. First of all, draw the graph of y equal to 1 minus x square. So to draw the graph, you need to know where these graphs intersect. So you can do a formal calculation to do that. Where does this curves intersects? So you just solve these two equations to get the points where it intersect. You will see those points. Like let me draw first of all the graph. So how will be y equal to 1 minus x minus 1 whole square graph?
The hyperbola.
Yeah, but how it will look like? I mean, at x equal to 1, that will have what?
Y is equals to 0.
Yeah, y equal to 0 and x equal to 1 also, right?
Yes, sir.
Yes. So let me draw the graph. So what will be that? It will be like this. So when y equal to x square, so it will intersect at 1 0. To intersect to the x-axis at 1 0, right? Because and y equal to x square will be always the uh, other direction. I mean the positive x-axis, because whatever value you give, it gives you positive number only. So in that way, you can define this a convex function. So that is one. So another one will be x equal to y square over 8 plus 1. So this one also should intersect at 1 0 also. But how it will look like? How it will look like? This x equal to y square over 8 plus 1. So it will intersect at 1 only, but it will be like this. This, right? I mean it's like this, and the region what we the uh, our domain of interest is this, right? This is our domain of interest.
Sir, in exam, how to interpret like this? I can find the point, but this graph, I can't.
Yeah, because you have to see the y equal to x square graph, you know, right?
Yes,
What
sir.
will be y equal to x square graph? That is this type of. I mean, at zero it is. When y equal to x minus one whole square, you just put this. This will move to here.
Yes, sir.
And
It's like graph.
when x equal to y square, x equal to y square graph is like this.
Yes,
But
sir.
x minus one equal to y square, that graph will be it will come here.
Yes,
Like
little
that.
bit intersect. Yes, sir.
Yeah, so that's how we don't need to remember x y equal to x minus one whole square, that curve itself. So you remember only y equal to x square. So few things you have to remember. After
Yes,
that,
sir.
if some difficult things are coming, then you cannot do those things. It's not easy to do also.
Yes, sir.
So, but these things you have to remember that small things. Then you can do.
Yes, sir.
So now, once you know the reason, then you can find out the limit. So how will this limit will be? So for the limit, what we'll do, we'll vary this line from here to here. Do you understand what I'm telling? Let me draw it. Is oh, no, sorry. Oops. So we'll vary from here to here the which line? This line, and we vary from here to here, and the line will be this. So line will be this. So then what you have to do? So what will be the limit then in this case? So when you vary, first of all let tell me in this line, I mean, let me draw. In this line in this line, what will be the, which one will vary?
Sir, why?
Y will vary, exactly. So that's how we have to do. So one step by step. So y will vary, but y will vary from where to where? It is from this curve to this curve. So what is
Zero
this?
to.
No, it's not zero. It is varying, always varying. It is not here zero. It's always varying. First of all, tell me what will be the value of y here.
Sir, the
This one.
root 8x minus 1.
Exactly. So you are fully correct. So it will be no. It's not. You check once more. You tell me.
Root 8 into x minus 1.
No, this curve is this one. Do you see that?
Sir, yes. That is y equal to x minus 1. Whole
Yeah,
square.
exactly. So there then it will be,
Okay, okay, yes, sir, yes, sir. I
yeah,
got
y will be x minus 1 whole square. I mean, I'm telling that x minus 1 whole square, the lower limit of this will be x minus 1 whole square. What is the upper limit? That will be whatever you said, right? 8x minus 1. 8x minus 1. Is it okay?
Yes, sir, yes, sir. I got confused by that curve.
Yeah. Now tell me what will be x.
Okay, sir.
So if you vary this line from exactly vertically, I mean, you have a this type of thing. I mean, can you, yeah. So then, if you vary one line, this type of line from here to here, then that will be fine, right? What do you say?
Yes, sir.
Yeah. So then, what will be the limit? So limit will be x equal to 0 to x, you can put 0 to 4, right? I mean, so not 0 to 4. What first of all you have to try to find what is this point. So this point, if you find out, this will be 3, 4. So this you can intersect and you can find the solution. Okay, 3, 4. So if you see it is 3, 4. Okay. Yeah, so x should vary from then 0 to 3, not 4, 0 to 3, right? So once you vary 0 x from 0 to 3 and y you vary from x minus 1 whole square to 8x minus 1, then that will be the domain. And then you have to find out the area. I mean, you have to just put 1 times dx dy. Okay. So total that thing gives you, this gives you 0 to 3, 0 to 3. Dx will be, so dy will be 8x minus 1 minus x minus 1 whole square. So x square plus 2x x minus 1 whole square. So minus 1 times.
Sir, it's root of 8 into x minus 1.
Yes, 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 true, true, true. Yeah, correct, fully correct. So 8x root x. Yeah, root, you give it root. So this will be root also. Then okay, this will be root. So times dx. Now you know the your usual way to determine this integration, right? This is now one variable integration, right? It becomes
Sir, how you got 0 to 3?
0 to 3 is if for x you have to vary x and y also, right?
Yes, sir.
Yeah.
Sir, then how to get that value?
Sorry, sorry.
Sir, I couldn't understand how to you got 0 to 3 of
Yeah,
x.
0 to 3 will be x.
Yes,
If
sir.
you take y, I mean, yeah, if you take from y will be 0 to 4 if you want to take the other way.
Yes, sir.
I think you were asking also that question. So if you want to do from y first, then it will be 0 to 4, but it's x. X is from, I mean, your points are 1, 0 to 3, 4. 3, 4 means x equal to 3 only. X cannot be 4, right?
Yes, sir.
X can vary from 0 to 3, not 4. Your point is 3, 4, right? Maximum you can go, you have this type of domain. I mean, domain is this. And here you have 3, 4. And here it is 1, 0. Sorry, not, sorry, the limit will be 1 to 3. Yeah. Yeah, now it's okay. Now is it okay?
Yes, sir.
1 to 3. Yeah. This should be 1 to 3, not 0 to 3. Yes.
Yes.
0 to 4 will be when if you take y first,
Why?
then it
Yes.
will be 1 to 4. And then in that case, the limit will be 1 to 4. Then what will happen? You have to vary x. And when you vary x first, the curve, other curve will come first. Mean y square by 8 plus 1 to x minus 1 whole square equal to y means square root y plus 1. So 1 plus square root y. Then it will be like this. So whatever way you do, you try by yourself that you are getting same solution. And ask me in the if you face any doubt, any problem, you tell me in the next class.
Yes, sir.
Is it okay?
Yes, sir.
So if you have any other doubt, you tell me. Otherwise, yeah, we can do one or two questions. Otherwise, we will leave. So, but this was up to this. It was like important things, which I told already.
Sir, no doubt, sir.
Yeah. Anyone else? Has any doubt? So mainly the today's class was mainly on this double integral and first of all the continuation of beta function and gamma function and then the double integral. This double integral, yeah, it was interesting, I guess. So if you have any doubt, you tell me, you ask through mail or you have, I think, discussion forum.
Yeah, otherwise in the YouTube itself also, because this video, this is we are recording, which will be uploaded in the YouTube also. And yeah, so anyway, you can tell me. And these are some books and references for yeah. This and then thank you for your attention. Anyway, I'll be here for 5 more minutes maybe. For if you have any doubt, it tell me. Otherwise, yeah, we can end it. Also.
Thank you, sir.
Thank you.